Good day. Today we're looking at perpendicular and angle bisectors. The perpendicular bisector theorem. If a point lies on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So, if CD is perpendicular to AB, that's this right angle, and AD is congruent to DB. Those are my tick marks for congruency. Then the hypotenuses, AC and C to B, are congruent. The converse of this is also true. So if the hypotenuse, AC, is congruent to CB, then we know line CD is perpendicular to line segment AB, and we know, actually I'm going to put this in blue, and we know that line segment AD is congruent to line segment DB. Okay, let's put this into practice. Number 3. For number 3, we're going to be using the bisector theorem. For number 5, we'll be using the converse. Find the length of RS. Well, I noticed that RT and QS are perpendicular. I noticed that QT and TS are congruent. Therefore, RQ must be congruent to RS. 7x minus 22 equals 4x plus 5. Minus 4x plus 22. 3x is equal to 27. Divide by 3. My x value is 9. I need to plug this back in order to find RS. RS is equal to 4x plus 5, so 4 times 9, which is 36, plus 5 is 41 units long. There is my answer. I'm finished. All right, number 5. I'm given the hypotenuses, the diagonal lines are congruent. Therefore, these must be perpendicular, and AD and DB are congruent. 5x minus 11 equals 3x plus 17. And you are welcome again to use Desmos anytime you want in this course. Regardless of how you do this, you should get the same answer. You'll get x is equal to 14. Find the length of AB. You have two options. I'm going to work it both ways just to show you. I can use segment addition and say 5 times 14 minus 11 plus 3 times 14 plus 17 is equal to the length of AB. Or option 2, which is my preferred method, choose either A to D or D to B. I'm going to be doing D to B and say 2, because they are congruent, so 2 of them, 3 times 14 plus 17 is equal to AB. Whichever way you choose to do this, you're going to get that AB is equal to 118. Yep. Yes, 2 times 59, 118. I'm showing you both methods. You can pick the one you think is easiest. Please use Desmos, just type it in, but anyway. Try problems 1, 2, 4, and 6. All right, this is the conclusion of a perpendicular bisector. Let's look at angle bisectors. If an angle, or a point, is on the bisector of an angle, then the point is equidistant from the sides of the angle. So, if ray AD bisects angle BAC, so this line cuts this angle in half, and AB is perpendicular to BD, this right angle, and AC is perpendicular to CD, this right angle, then we can say BD is congruent to DC. The converse of the angle bisector theorem, if BD and DC are congruent, and AB and DB and AC and CD are perpendicular, then AD is going to bisect the measure of angle BAC. So these two angles will be congruent. I'm going to do problems 1 and 2, and I'll let you try the rest. Number 1, I notice that I have an angle bisector here because I have the tick marks here and here, the angle markers rather. I notice I have perpendicular lines. Therefore, I know these line segments must be congruent. 4x plus 30 equals 9x minus 5. Negative 5x is equal to negative 35. X is equal to 7. Finished. Number 2. I notice I have congruent line segments here and here. I have right angles. Therefore, I must have an angle bisector. Each side is congruent. 5x minus 11 is equal to 8x minus 41. I'm going to add 41 to both sides, subtract 5x from both sides. If you wanted to know the degree of the top one, 5 times 10, 50, minus 11, 39 degrees. 80 minus 41 is also 39 degrees. Each side is 39. And the entire thing would be 78 degrees. Now I show you that not because the problem asked for it, but simply because you may have to do that here in a minute when you practice numbers 3 through 6. Okay, pause the video, try these. Here's your answers. This is all that I have for you today, and I hope you have a great rest of your day.